Hello, this is Jose Luis here at Parametric Camp, and welcome to this video where I would like to teach you the foundations of how to draw 2D graphics using web technologies. And for that, in this first video in this series, what I would like to teach you is how to use the Canvas API. Canvas API is the fundamental native way that we have for doing 2D graphics that are web-based, and it does look something like this. It's very inspired by SVG graphics, and it allows you to define colors, to define styles, and to draw primitive shapes using web technologies. As a bonus, I'm going to show you at the end of the video how to do a little bit of interactivity, like I'm going to click here and I'm going to get on the console a message saying, giving me the coordinates of where do I draw, which will be very helpful in order to understand where do I want to draw things. This will be really good if you want to understand the core native technologies of how to do this, how to do 2D graphics. And it will also be very useful to understand what is the foundational technology that all these libraries and all these APIs and all these cool repositories of code use to make this a little faster, easier, and more fluid. We will get into why that is necessary further down this video. And in this video, I'm going to show you how to do this very simple example, like a basic house in the prairie. Okay, so let's talk in and more drawing. Fantastic. Let's get started. So before we go into any coding, of course, what I would like to do is I would like to explain that the first steps that we're going to take into learning how to create drawing apps with web-based technologies is to understand what the basic technologies are that we have available for us. And what I would like to introduce you to in this video is the most foundational one, which is what we call the Canvas API. The Canvas API is basically an invention or an application programming interface that was developed when the HTML specification reached version 5. What that means is that when the internet was developing and when HTML, which is one of the main pillars of web-based development, was developed, there was the need, sometime during the process, to create some kind of graphic element that we could insert in web pages and that we could use to draw 2D or 3D graphics. Before version 5 of HTML, that didn't quite exist, so that's why things such as Flash or those kind of things were pretty popular before that version. But then with HTML5, this new HTML element called Canvas was invented and was specified. And then this became the main entry point for anything related to 2D and 3D graphics that are web-based. So what the Canvas API is basically a way, or you can almost kind of think of it as a mini tiny programming language for drawing things on a web app. What that means is that the way it works is that if you insert an HTML element of the type canvas in your web page, and then using some JavaScript code, you fetch that canvas element, you take the context, you create a context where you can draw, and I will explain what that means in a second, and then you use that context to draw things on that canvas window, then you can create very simple drawings, right? One of the main elements, or the one that we're going to be discussing in this video, is the 2D rendering context that is canvas based. What that means is that this is a super, probably the simplest API that we can use for drawing 2D graphics on the screen. It's very simple, and we're actually going to develop a very similar example to this, like a tiny prairie house. Ours is going to be a little bit more colorful, but it's going to look something like this. And as you can see, the programming language, if you will, or in other words, the API, is actually quite simple. It's just a single stream of commands that are related to 2D graphic entities like rectangles, circles, changing colors, etc. So it's actually super simple. It's very straightforward. You're going to see that if you've ever done any 2D graphics or you're familiar with Photoshop or Illustrator, it's going to feel very natural to you. Okay? So, all right. So let's talk in. And before we actually start doing any of this, I would like to first get into setting up what our development environment is going to look like. Let's do it. So for our development environment, we're going to be using this development environment called Visual Studio Code. So if you haven't, I'm going to open it right now, and I have it here on my other screen. If you have never used it, Visual Studio Code is a very simple text editor that also has code compilation and code checks capabilities. It's actually really good for cross-platform and cross-language development, and it's particularly good for JavaScript because for among other things, it's actually built itself using JavaScript. So not to be confused with Visual Studio, which is a different development environment, the one that we use mostly for C# development, okay? So what I've done for these videos is, and what I'm going to be doing throughout this playlist is that I have created a starter project. A starter project is basically a folder where if I open it, you can see that I have an index.html, a script file, and a CSS file. So I'm going to drop that into Visual Studio, and you can see that I have my main entry point and index file. I'm going to make this a little bigger. And then I have here a script file with this very simple console dump and my styles.css. All right. And this is if you don't know what I'm doing here, I just don't want to waste a lot of time typing this. You can find this starter project in our parametric tutorial files. There is a folder here called web-based drawing where I'm going to be uploading and there's a folder called Hello Canvas Start. So I'm going to be uploading all the starter projects to this repository. So you're going to find a link to this repo on the description of this video. So feel free to go there right now, pause this video, download the starter project, and then resume this video as we go, okay? And then the next thing that I'm going to do is I'm going to run this project, this base project on my browser. There are two ways of doing that. So I could just open Chrome, which opens on my other screen. I could just open Chrome and then take the index file and drop it on Chrome. That is a perfectly good way of opening a static HTML project, right? And if I actually inspect you can see that I have my canvas element, my JavaScript element. If I go to the console, you can see that the console did dump a message called Hello Canvas, which is coming from the script file that I have attached to my project. All right, so which I'm loading right here, and I have a simple message, right, to just make sure that things are working, right? However, the problem with this idea, the problem of dropping a static HTML page on Chrome and then using that as a way to develop a website is that it's a little cumbersome, because the problem is that if I now change any part of the code, so this is a change and I save the file, the website does not automatically update. You can see that there is no new dump here. That is because browsers load a web page once and then they're done with that. They're not constantly looking for changes on the server or any of those things. So what I will need to do is I will need to go here and reload my page to see the changes take effect. And because I'm going to be doing so many changes, it's going to be kind of cumbersome. So for that reason, I'm going to use a technique that a lot of people use when developing with Visual Studio Code, which is starting a virtual server that is going to be running on the background on my machine, that is going to be listening to changes in the code. And whenever there are such changes in the code, it's going to force the browser to reload itself. Okay? How do I do that? I do that by going to the extensions tab on Visual Studio Code. And then here I'm going to type live server. Okay. And then you're going to search for this project that a lot of people are using. I already have it installed, but you basically click here, you click install, etc., etc. You can see that it has 44 million downloads and very good ratings, right? And then what that does, once you turn it on, is that you will get here, I don't know if you can see, there is a tiny tab called Go Live that is right now hidden by my chair. But yes, I don't know if you can read there, click to run live server, all right? So when you click there, you can create a server and it will run. I actually like doing it a different way because sometimes I have many projects going on here. So what I like is to click on the file that I actually want to be the base of the server, right click here and say open with live server. All right. If I do that, if I open with live server, you can see that my system triggers Firefox, which is my default browser, but I don't like Firefox for development. I like Chrome much better. So what I'm going to do is I'm going to copy and paste the address of this live server, which is 127.0.0.1 blah 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 index.html. I'm going to inspect the files. You can see that in the console, hello canvas, this is a change, and live reload is enabled. And now if I make any change, so this is another change, right? And if I save the file, like Control S, you can see that this just updated. And now I can just do another, for example, hello P campers, all right? And then I save that, and then I get another console dump, okay? So now I have an integrated development environment where I can change things on my project here on the right screen in Visual Studio Code. And any changes that I do as I save the files, they get updated on my browser, which is what I'm going to use to see those changes. Okay, so things are now tight. I have a very fluid development environment. I think we are ready to start actually drawing things on the screen with the Canvas API. Let's take a look at how to do that. All right, before we start, let's take a look at the structure of the project that we're working with. As I said before, you have on the GitHub repository the starter version of the project. I'm going to be working on the full version so that you can also download the finished thing if you're watching this video in the future. And the full version is going to have these three parts. It's going to have the main index file, the one that we're loading and the one that we could upload to our website online. It's going to have, this is linking to a CSS file with a bunch of styles. These styles, the only thing that they're basically doing is they are making the canvas, which we can see here, they're making the canvas stay centered vertically and horizontally on the screen. If you don't do this, it would be just on the top left corner. It's not a big issue. I just like it centered when I'm working on like this single page web drawing applications. And then the index file is also linking to the main script file, which we have here under JS script, which is where we're going to be writing all of our code, right? So this is the main place where we're going to be working with. And what I would like to do is I would like to teach you now how to use the Canvas API to draw 2D graphics on this canvas element that we have created as an HTML element, all right? So what is that going to look like? Well, the first thing that I'm going to do is I'm going to create a very simple, I'm going to turn off Google Copilot because otherwise it's going to be a little annoying. So the first thing that I would like to do is I'm going to write a very simple scaffolding, which is going to be, I'm going to create a function that I'm going to say draw house, for example, and I'm going to open and close parentheses. And then whenever this function is called, this function is going to write or execute whatever code is required to draw this house on the screen. For right now, we're just going to write a placeholder. So for example, I am about to start drawing a little house. All right. And I'm going to wrap my line so that we can all see everything. All right. And I'm also going to just close this to make a little bit more room. Okay. So beautiful. I'm going to save this. It just restarted, but the console did not dump this this message. This is because right now I am loading this script. The script is loading this function that has the capacity to dump things on the screen, on the console, but no part of my script or my code or my HTML is running that function. So I need to execute that function. One trick to do this, one way to do this is to execute the function whenever the entire window or the entire web app has finished loading. So the way to do that is execute function when window finishes loading. A way to do that is by looking at the window object, which is going to be always available in a web app as part of the JavaScript framework, and then overloading or overwriting one of the handlers that are available in that object. So for example, the window object has a property called onload, which we can override and we can replace with whichever function we want, so that whenever the window loads, that function will be executed. So what I'm going to do here is I'm going to say, I want, whenever you finish loading the window, I want the function that you execute when you have loaded it, I want it to be the one that I just defined, draw house. And then if I save this, you can see that now this function is executed once whenever this finishes loading. This is also interesting because if this web page was very heavy, it had a lot of elements, the drawing doesn't happen until everything has loaded, so that we have access to all the information. Beautiful. Then the next thing that I'm going to do is, in order to use the Canvas API, the first thing that I need to do is, one, have access to the canvas. So I need to be able to fetch the canvas element, the HTML element, in my JavaScript side. And then from that element, I need to extract what is called the drawing context, or in other words, this rendering context 2D. Okay? Because it is the context that I'm going to be using as a mediator to call all the drawing functions that I want to execute in the canvas. Think of the canvas rendering context as a middle person between your code and the actual canvas that is on the page. All right? The way to do that is actually quite simple. So I'm going to define a variable that I'm going to call canvas, and I'm going to go to the document object, which is always available in a web app, and it represents the HTML document. And I'm going to use the getElementById function. Why am I doing that? Because in my HTML, on the canvas element, I already gave it a name, if you will. I gave it the ID of 2D canvas, so that whenever I want to use JavaScript to fetch that element, I know exactly which one to cherry pick by name. This is very helpful if I had many different canvases and I was drawing many different things on the same web app. Being able to choose which one I want is actually quite important, right? So beautiful. So now this variable contains a link to the 2D canvas HTML element. From that, what I need to get is my context. The context is going to be this API, the API that I use to draw things to that 2D screen. So from that, what I'm going to do is canvas dot, and then I'm going to get the context. I'm going to get the context, and the context is going to be a 2D context. Why do I have to specify 2D? Because surprise, surprise, you can also do 3D with Canvas using WebGL and all that cool stuff, but that's going to be a completely different beast, which we may or may not cover farther down on this playlist or in some other playlist. I don't know. But if we do, there might be a card popping up here in the corner, or you may see the videos at the end of this playlist. I don't know. We'll see what the future holds for us. All right. And then once we have the context, then we can use that context to draw things on the screen. Okay. So what is the first thing that I'm going to do? Well, I'm going to, for example, draw a background. The background is basically just a very large rectangle. Okay. So what I'm going to do is I'm going to say the style that I want is going to be some color. So for example, I'm going to say light gray. All right. And the next thing that I'm going to do, I will explain what this is. What I'm going to do is I'm going to create a rectangle that has a fill, and I'm going to specify a few coordinates. I'm going to specify 0, 0 as the first coordinate, and I'm going to specify the width and the height of that rectangle. Those, I actually know them because I hard-coded them here. So I could basically just say 600 and 300, but I'm not going to do that but I will explain why we're not going to do that later. So I'm going to save this file, and you can see that the moment I do this, the actual canvas element highlights with a gray background. Again, a background, which is not really a background, it's just a big rectangle that is covering the entire canvas. Okay? Now, why this? Where is this coming from? As I said before, I want you to understand the context as a middle person between the JavaScript code that we're writing on your web app and the API that you need to access and to have pixels turn on and off on your Canvas HTML element. The context is very important because if we go to the documentation, the context is the place where we have access to all the functions that allow us to draw things on the canvas. So if you go to the documentation, you can see, for example, that the rendering context does have a lot of properties. So for example, the direction, the fill style, the line cap, the line joints, the line width, all of those are things that you can change and that will affect how the whatever you draw after those changes is going to look like. And then it has methods, which are basically the functions that you can call to have pixels turn on and off on the canvas based on some kind of geometrical logic. So for example, you can draw arcs, you can draw paths, you can set the fill color, you can draw a rectangle with a fill color, you can draw a rectangle with no fills, you can probably do a circle. Is there a circle? There might be an ellipse. Where is the ellipse? Yeah, there is an ellipse here. There is like, you can rotate stuff, you can scale stuff, you can transform, you can do many, many different things. So for example, as I said before, this will be a super simple example to draw a prairie house. So what we've done here is, in order to draw the background, we took the context, and from the context, we did change the style for the fill color. All right. And for the fill style, it's very important, always check the documentation, of course. For the fill style, you can see that what you can use is either CSS named colors, or you can also use other ways of defining color. Like for example, you can use RGBA definitions. So for example, what I can do here is I can say, instead of a named color, I can specify my custom color, which is going to be a bright red, by just typing RGB 255, 0, and 0. And you see that I get really bright red. Any way you can specify color in CSS language, fill style will accept that exact same definition. So I can also use, for example, hex coloring, right? And I still get the same result. I should have done a different one. So for example, like this, right? And I get bright green, okay? So I'm gonna go back to light gray, I think. And then now, for fill rectangle, you can see that this is an instance method, right? So if I go here, fill rectangle, you can see the two parentheses here. That means that it's basically a function that lives inside of the context. So I need to call it, and I need to give it some parameters. So if I go to the documentation, this is something that you should always do. Fill rectangle, you can see that the syntax is the X and Y coordinates of the top left corner, right, of the rectangle's starting point, and then width and height, the dimensions of that rectangle. Now, you know that I like to be as parametric, as procedural as possible. This is hard-coded size. So if someone were to now make the canvas a little bigger, right, you can see that now the canvas, we have this chunk over here that didn't get color because the width on the HTML element and the width on the code are not properly linked together. So a better way to do this is by trying to figure out the width and the height of the canvas element from the actual canvas element itself, which we have it here as a variable. So something that I can do is I can say canvas.width. I can read the information from there, and canvas.height. All right, and if I save that, you can see that now it updates properly, and if I were to change the size of the screen, everything will also update properly. Yoo-hoo! Fantastic! All right, so are we ready to now go all the way in and try to draw like a cute little colorful prairie house? So let's plan what we're going to do. I think the drawing is going to look something like a blue sky with some green ground, and then a house with like a red, with some red roof and like a tiny tree here, maybe like a sun or a bird. I don't know what that looks like. But let's start with the background. So the background is going to be some kind of blue. So I already have like here, like some numbers and some values that have worked for me before. So I'm going to be doing a light bluish, all right, for the background. Now, what I'm going to do is I'm going to draw some ground here. So that's going to be a rectangle that is going to be somewhere here, okay? So the ground is going to be, first, I'm going to change the color of the fill. So fill style is going to be some new color, RGB, for example. I'm going to make it like a light green, I think. So 64, 156, and 20. And if you don't know like these RGB values, what I highly recommend is that, for example, you check CSS colors, and you can see that there's like all these websites that give you, I actually like this one a lot, all these websites that give you named CSS colors like lime green, dark khaki, tan, sandy brown, coral, whatever. And then if you can actually read the hex description of the color there, or you can just use the name itself. So I could write here, for example, um, context.fill style. I could write here coral, any of those name colors will work. And then context dot fill rectangle, and I'm going to use the coordinates are going to be, remember in Canvas, I didn't explain this, in Canvas coordinates, the 0, 0 is right here on the top left corner, the positive X direction is this one, and the positive Y direction is this one, which can be a little weird if you're coming from 3D modeling environments where the origin of coordinates is typically here. Here is on the top left, positive X is this way and positive Y is this way. So the coordinates are going to be X is going to be 0, Y is going to be somewhere here. So for example, let's do 200. And then the width of the rectangle is going to be the width of the canvas, so the entire screen. And then the height is going to be, I guess we could do canvas height minus 200, right? Which is this distance that we had here. So that would be what, 100 right now? So let me save this, and you can see that I get this coral rectangle here. Of course, I don't want it to be coral. I'm going to do green. So I'm going to have this like darker green over here. All right, beautiful. I'm going to now draw a tree, okay? So for the tree, I'm actually going to draw it as a stick, as a line like this. The problem is that the canvas, the context, doesn't really have a line function. It has this thing called line to, which relies on this idea that you're already somewhere and that you want to go to somewhere, okay? This is because some of the logic of the Canvas Context API is coming from SVG drawing, which did have a very particular way of drawing paths. So the way that works is that when you want to draw line work, the way you have to do that is by creating a generic path and then basically specifying all the vertices of where you want to go. And that also includes simple lines. So for example, the way that works is, let me say that the line width is going to be, for example, 10 units. And let me specify that the stroke, the color, stroke style is going to be, for example, black. We will find a color later, all right? And then what I do now is that in order to draw any linear element, the way to do that is by starting a path. So I'm going to say to the API, I want to begin drawing a path, all right? At this point, the API picks up all the style changes we've done. And then what we do is we basically imagine that we have this cursor or this location that we're going to be changing around in the canvas. So the first thing that we do is we're going to move this virtual cursor somewhere on the screen. And this move motion does not really draw anything. It just places the cursor somewhere in this imaginary virtual screen that we have. So for example, I'm going to move it to coordinates somewhere over here and over here. So 475 and 230, something along those lines, right? So right now our cursor is somewhere here, if you can imagine. And then what we do now is once we have it somewhere, then we use the line 2 to specify a second set of coordinates, and that is where we're going to move next. Our cursor will be placed in that position, but it will draw a line between those 2 points. So 475, so it's going to be a vertical line, and 145 so that it goes a bit vertical like this, okay? And if I save this, you can see that nothing happens, because on top of that, something that I need to do is, in order to actually have those lines drawing, I need to specify that I want, for my path, I want all the parts that had lines to be stroked. So I'm going to save this, and you can see that now the line shows up, and I have this very thick 10 pixel wide line from the move point to the line 2 point, okay? I know what you might be thinking. If you're coming from other drawing environments, this kind of 4 lines of code just for drawing 1 line, it's a little bit of an overkill, but yes, it is what it is. But it does have some advantages when we're drawing in some other more, perhaps like, what am I going to say? In other, some other more complicated paths, if you will. Now let's continue the tree. What I would like to do now is draw some kind of circle on top of the tree that feels like the leaves of that tree. So if we go to the Canvas Rendering Context API, you can see that there is no such thing as a circle. We have the ellipse method, but the ellipse method is for ellipses that have 2 different radii, right? And so what I'm going to use instead is I'm going to use the arc function. If you think of it, a circle is basically an arc that is gone a full 360, right? So what we can do here is, in order to specify a circle from a center, we can specify from an arc the x and y, the center, constant radius, and then the start angle and the end angle are going to be 0 and 360, so that we have a full circle, right? Again, it's a little convoluted, but it is what it is. Like, if you think about it, arc is a more flexible and more generic way of drawing a circle, which is, in a way, a special case of the more general case, which is drawing arches, right? So what I'm going to do here is the tree. I'm going to set, for example, the fill style, and I'm also going to make this black for the moment. We're going to change colors in a second, all right? And I'm going to follow the exact same pattern. So I'm going to begin a path, all right? And then I'm going to draw an arc. And remember, arc, as I get here on the description, x and y is the center, the radius, whatever value, and then the start angle and the closing angle, the end angle. So the center is going to be whatever I ended drawing my line. So that's going to be that. And then the radius is going to be some random value. So for example, 38, whatever. And then the start angle is going to be 0 and the end angle is going to be 360. But remember that most graphical environments work with radians. So what you need to do is you need to do 360 in radians is 2 pi. So you have to do 2 times dot math pi, because the JavaScript API does not have tau, as I totally would wish, right? And then in order to actually, wait, so let's save this. You can see that we still don't get the circle drawn, because we do have to, as I said before, whenever we define paths, we will have to specify from what we have drawn, what do we want to draw as a stroke, or what do we want to draw as a fill geometry, right? So what does that look like? Context dot fill, right? And what that will do is that any geometry, any shape that you have drawn, that you have specified in the path before the fill, will be drawn, but instead of with a stroke, it will be drawn with just a solid fill color, right? So if I do that now, you can see that, boom, I get the circle right on top, okay? And of course, this is really, really ugly. So I'm going to specify a few colors from an example that I had before. So I'm going to specify some kind of like brownish color. Again, I could do that with CSS colors. I probably should do that with CSS colors. So that's why not. Dark golden rod. Rod. Dark golden rod. I don't know who decided CSS color names. Dark golden rod. And then for this, I'm going to specify some kind of very dark green. So I'm going to choose, for example, literally dark green here. Or even darker. Is there anything darker? Sea green. I'm going to specify sea green. I like that. Sea green. Up, and then there we go. Okay. Beautiful. All right. Fantastic. So with this, we have now the tree. So let's go for the house. I want to draw a house here with a triangular roof. So a house is going to be, basically the main body is going to be a white rectangle. So I'm going to say fill style is going to be white, and I could type white here. Or I'm going to be a little nerdy and I'm going to define white in hex, which is very easy. Is FFF, or so 3 Fs or 4 or 6 Fs, depending on, it doesn't really matter, right? So fill style is going to be that. And then I'm going to context.fill rectangle. I'm going to draw a rectangle from coordinates 280 and 190, and I'm going to make it like 20, no, I'm going to draw, sorry, so, and it's going to be a square, so 120 and 120. Oh, that's too low. I don't like that. So I'm going to move that a little to the left, so 230, and I'm going to bump it a little up, so 130 here. Yes, I like it better now, much better. So I'm going to draw a door. So it's going to be a small rectangle in front of the thing. So context.fill style, and the color is going to be, what am I going to do for color? What color do we want the door to be? The door is going to be orange or Indian red. I like Indian red. So let me type here Indian red. Okay. Oops, sorry, Indian red. And then what else am I going to do? So I'm going to do a fill color, a fill rectangle, and the rectangle is going to be 280, 190, 20, and 40. Okay. Oh, no, not working. So what am I doing wrong? So 20 and 40, is that too? Give me 1 second. Yes, I think this is a little too high. So yes, I'm going to short. Yeah, exactly. All right. And now what I would like to do is I would like to draw like an outline, like the frame of the door, right? What I'm basically going to do is I'm going to draw a rectangle around the fill rectangle, but this one is going to be only a black line. Okay. So context.stroke style is going to be black, and black can be either black, or I can do the hex version of it, which is either 3 zeros or 6 zeros. That is also a way to define black. And then context dot, I'm going to say that the line width has to be 1. I'm actually going to cancel this for a second, and you're going to see why. And then context dot rectangle, I'm going to use a stroke rectangle, so rectangle with no fill color, and I'm going to use the same coordinates as this thing, so the exact same one. If I do that, you can see that I get this really, really thick line. Why is that? Because if you remember, at some point when I was drawing the tree, I set the line width of the context to 10 pixels. And remember that any changes that you do to styles, they broadcast and they stay permanent unless you change it otherwise. So if I now set this back to 1, from here on, any stroke that I draw is going to be only 1 pixel wide. Okay? Beautiful. What about the roof? What can we do here? Well, I'm going to say that the roof is going to be some kind of triangle here, and the roof is going to be, for example, fill style, and that's going to be, what are we going to do for the roof? What about a sandy brown? I really am, I really like sandy brown. Okay, then what are we going to do? For the roof, because it's going to be a triangle, I'm basically going to have to define a path that contains the three vertices of this triangle, right? So context dot begin path. I'm going to now move my virtual cursor, if you will. Remember, I'm going to move it to the place where I want to start drawing, and then I'm going to start drawing line, line, line to different vertices. So I'm going to go somewhere in the middle of the screen, so that's going to be 200, and probably somewhere around here, probably like, what, like 130, all right? And then the next, I'm going to draw a line too, and that's going to be somewhere, for example, somewhere probably here. So that's going to be 380 and somewhere a bit lower. So that's going to be 130. Maybe it's not lower. What? Okay. And then I'm just going to try and stroke what I just did. Okay, to make sure that it's working. Okay. So 200, 380. So I have now one line. Okay. So I can add here more vertices. So I can say line 2 and somewhere here 290 and 70. Okay, so for example, and you can see that now I get this. And then I could draw another line here because I know the coordinates of that point. But actually, the context API does have a specific function that I can use to just, whatever I am, go back to the beginning of the path, right? And that is by using close path. So if I save this, you can see that I now get this, and I have the stroke. And what I want to do now probably is I want to fill this with the fill style color, right? So I'm going to save this. But you can see that the fill goes over the stroke. So if I change the order and I do the fill first and the stroke over it, then the fill color is not overlapping on top of the stroke. Okay? So beautiful. So that is about it. How did you like this, huh? All right. Wait, but should we try something else? Let me think about this. You might be wondering yourself, like, but Jose Luis, how did you know exactly like the coordinates of all the vertices? You were like getting it so right at the first, right? Well, I have to admit, I have a cheat sheet. I did practice this before, and I was basically copying from this place where I had all the coordinates before. But in order to actually find those coordinates, I did use a personal trick, which is if you are drawing, you may want to have a sense of where you're drawing by basically moving the mouse around and then getting the coordinates of where that mouse is, right? Well, it turns out that there is something that you can do in order to figure that out, which is override some of the canvas properties that get triggered whenever you interact with that canvas. One of those properties is called on mouse down, which is triggered anytime you click on the canvas, right? So the way you can do that is you can say, for example, here you can go and say canvas, canvas.on mouse down, right? And what you can do is you can define your own function here in order to override whatever the canvas does by default when someone clicks on it. The way to define that is you could define a function here, for example, event, and that's going to be whatever, or you can do the arrow notation to just write a shorter version of this. So you can write here e or event is going to be whatever. So this is what's called declaring an anonymous function in JavaScript. It's basically the exact same thing as what I had before, right? These are the exact same things, except that I've changed e for event. It doesn't really matter, right? And then what we can do here is, first of all, let's see if this is working. User clicked, all right? So I'm going to save that. It gets reloaded. And now if I click, you see that I'm getting in the console, I'm getting messages that someone clicked here, all right? Fantastic. So now what do we do with this? So what I can do is, first of all, from the canvas, I can get the bounding rectangle. I can get like a shape that represents the rectangle that the canvas forms. So for example, I'm going to call this rect, and I'm going to say canvas dot get bounding client rectangle. All right, and I can actually print that to the console. And if I click here, you can see that I get this DOM rectangle with bottom, height, left, right, all these properties, right? And then what I can do is I can say, but this only describes the rectangle of the canvas. It doesn't describe where the mouse is in relation to that canvas. So for that, I'm going to need to do a little bit of calculations, and the calculations are going to be the following. So when I click on the canvas, I get this event object that gets passed by the API to the function. The event object has a bunch of information that is important to learn from, so I'm going to dump the E event. So I'm going to click here, and you see that I have the mouse event, and I have a bunch of coordinates: client X and Y, layer X and Y, page X and Y, screen X and Y. There's many different coordinates. Let me be a bit more intentional. I'm going to click very close to the top left corner here. And if I do, what you can see is that nowhere do I get 0, 0, which is what I'm looking at right now. I get this layer X, layer Y, but what I get is basically where the client is in X and Y, but with respect to the top left corner of the page. But because from the rectangle, I know what the left and the top coordinates of this rectangle are, I know where these coordinates are from this rectangle, I can do a very simple calculation and say the X coordinate of the mouse on the canvas is the client X property of the event, so the coordinates based on this top left corner, minus the coordinates of the top left of the rectangle of my canvas. And then for Y, I can do e.client Y minus rec.top. Okay? And then I can print to the console. I can print to the console. If I manage to type it, I can print to the console. Mouse click on canvas, and then here I'm going to use X and then Y. Okay? And I'm going to close with the back tick. All right. And then now if I click very close to the top left corner, I should get something close to 0, 0. I get 1, 2. And if I click all the way here, 500 and 600 and 300, right? This is very useful because by doing this, I can give myself a very quick way of going over the canvas and say, I need to draw a rectangle here, somewhere here. So if I click, my coordinates are 42, 158, and then I can just go here very quick and say context, fill rectangle in these coordinates and 100 and 100, for example, and you see that I get a rectangle more or less on the top left corner of where I clicked. Okay, beautiful. So that is just basically a small hack to try to understand how to figure out where certain coordinates are on the screen. Of course, as you can imagine, this can also be the entry point to do some interactivity. So maybe I click and I want to draw more things when I click on certain parts of the canvas, right? However, what we have seen in this video is basically a way to use the raw, the pure, the baseline API that all apps and all frameworks and all libraries who want to do any 2D drawing that is based on web technologies, all of them have to use this Canvas API underneath. Okay? So this is the foundational technology for any drawing that you want to do on a screen, on a canvas, on a web app. However, as you may have noticed, this API is very verbose. In order to just draw a simple line, you require like many lines of code. It could get a little tedious. It could get a little convoluted. It's not, let me put it this way, it's not very flexible. It's not very fluid. It's not fast to type, right? It is very solid. It is the most performative way you can draw 2D graphics on the screen, with an asterisk, unless you're using WebGL for 2D, the different story here. But it's the most performative one. However, it might not be the most fluid. So what I wanted to do in this video is I wanted to show you the foundation so that you understand where the technology comes from. And if you want performative applications, you may want to use this way. But if you want to just like tinker with drawing things in a fast, fluid way, then what I would actually recommend is that you check out the P5JS project, which is a library for 2D interactive graphics that is web-based, and that it makes doing this much more fluid, fast, and easy, all right? And which is going to be what we're going to be doing in the next video on this playlist. So please join me on the next video if you want to see how to do this same thing, but faster, easier, and perhaps more interactive as well, okay? So see you on the next video where we're going to be drawing a tiny house on a prairie using P5JS. And in the meantime, if you thought this was useful, fun, interesting, or any of the above, maybe you want to consider liking this video, subscribing to the channel, and showing that kind of appreciation that we do these days on YouTube. Thank you very much, and see you on the next video drawing using P5JS. Bye-bye.